So an alkene polymer are formed when smaller molecules called monomers are repetitively bonded together to make large molecules. So specifically, we're looking at alkene polymers, but alkenes aren't the only ones that do this. Other things do this as well, but for this chapter, we're looking at alkene polymers. So many alkenes undergo polymerization when they are treated with a catalyst. So there's several, we're going to look at these three specifically. So ethylene, when it undergoes polymerization, makes or yields polyethylene. And then propylene, whoops, didn't mean to mark it out. Propylene will yield polypropylene, and styrene will yield polystyrene. So it could depend on how many units there are within the polymer. It could be a few hundred to a few thousand units, just depending on the polymerization. So here's an example of kind of what it looks like structurally. So what they do is, this is ethylene right here. That's the alkene. And when it's polymerized, it becomes polyethylene, and these parentheses are there to show that there are repeating units of that. And usually they'll put a subscript right there to indicate the number of repeating units. So over here we have propylene, polypropylene, styrene, and then polystyrene. So this is just an example of what they look like structurally. So to actually make a polymer, there's a few steps. So an initiator, which is shown right here, attaches to the alkene, and the reactive intermediate is formed. So this is the reactive intermediate right here. And it has what we call a radical. So you can see this unpaired electron right there. We call it a radical. And then it comes and attaches to a alkene right here, which then forms another reactive intermediate. So I don't know if this is going to mess up if I draw over here. Yep, it did. So you can see the radical right there is formed. So it just keeps doing that. It forms the new reactive intermediate. That reactive intermediate attaches to an alkene, forms a new reactive intermediate, attaches to another alkene. So this is how all these alkenes come together into this polymer. And then we put parentheses. So here's our parentheses with the subscript indicating the number of repeating units in that polymer. Okay, now the last thing for this chapter we're going to talk about is aromatic compounds. Aromatic compounds contain a benzene-like ring. So benzene is actually this molecule right here. Okay, benzene, there are, the formula for benzene is C6H6. And there are 3 double bonds located in the ring. So you can see right here, right here, right here. So usually when you draw this, it doesn't matter where the double bonds go. Okay, I can put them here like this, or I can put them like this. Okay, so it doesn't really matter where the double bonds go, and I'll explain that here in just a second. Well, I guess I could do it right now. So what's happening is there's resonance structures, and anytime you get resonance, that means that these double bonds are shared within all the carbons, all 6 carbons there. So a lot of times you'll see the benzene ring looking like this. They'll put a circle in the middle. So that's just showing the resonance, showing those double bonds are shared between all the carbons. So that's why it doesn't matter where you put those double bonds. So this is an aromatic compound. Again, it's a benzene-like ring. I'm going to show you some common aromatic compounds here. Or not common, I'm sorry, simple monosubstituted aromatic compounds. So here We have fluorine is attached to the benzene, chlorine, iodine, all attached to the benzene ring, bromine, and then NO2 we call nitro. So nitrobenzene there. So if you just have one substituent attached to the ring, there's no need for you to put the number that it's attached to, the number, for the carbon, because it's always going to be attached to 1. So it doesn't matter which carbon you show it on, that's always going to be carbon 1. Now, when we get multiple substituents, that's when we start adding in the numerical prefixes. So here's an example of that. Okay, so on the first one, we have 2-bromine. So we can number them 1 and 2. So bromine 1, bromine 2, or bromine is connected to carbon 1, bromine is connected to carbon 2. And we could name it 1,2-dibromobenzene. Or we can use the prefixes ortho, meta, and para instead of numbers. So if the substituents are only 1 carbon away, then I'm going to use ortho. Okay, so it'd be ortho-dibromobenzene. So that's the same thing as saying 1,2-dibromobenzene. And then if my substituents are 2 carbons away, I can use meta. So here, I have nitro on carbon 1, chlorine on carbon 3. So I could say 3-chloronitrobenzene, or I can use meta and just say meta-chloronitrobenzene. And then over here, if they're 3 carbons away, so this example says 1,4-dimethylbenzene, or I can just say para-dimethylbenzene, same thing. So you might see that a lot, the O, M, and P, but just know the different spacing, okay, how far apart they are. Now here's some common names of aromatic compounds. This was the slide I thought I was getting to just a minute ago. So you do need to know the names of these aromatic compounds, so make sure you memorize these. So again, we have all these benzene rings and we have these substituents connected to them. So if I have, wrong way. If I have a methyl group attached to a benzene ring, then we call it toluene. So again, I want you to memorize these, okay? If I have an OH group attached to a benzene ring, I call it phenol. If I have NH2 attached to a benzene ring, I call it aniline. And then COOH, which a lot of times that will be looking like this, okay? So COOH is called benzoic acid. We'll get more into that later in the semester. Benzaldehyde, again, that's going to look more like this, and the carbon is attached to the benzene ring, and then OCH3 is called anisole. So make sure you know the names of these common aromatic compounds here. We can also use an aromatic compound as a substituent group. So if I have a long carbon chain that's longer than 6, right? Because that 6 is the how many carbons we have in benzene rings. So if I have more than 6, like here, I have 7 carbons. So that means my 7 carbons there are the parent chain. So this aromatic compound is considered a substituent. So we name that substituent as phenol. Okay, so here it's on carbon 3, so it'd be 3-phenylheptane. Phenyl, however you want to say it, phenylheptane. Okay, so now let's name these. So a lot of times we're going to be using the common names of those aromatic compounds. That's why I want you to memorize them. So here's our aromatic compound. Okay, and I can see I have CH3 attached to it. So I know that that's going to make it toluene. Okay, so That's what I'm doing first, identifying the parent organic compound. So I have toluene. That's my first step. Okay, whoops. Then I need to identify the location of the second substituent, which is 3, right? So we want to start with 1 where the methyl group is, and then go over to the nitro group, which is 3. And then I can name it. So it's going to be 3-nitrotoluene. So we don't have to use benzene because, what's in the red circle there is toluene. So we just write 3-nitrotoluene. Oh, or you can use meta. I forgot about that. Whoa, I went too far. Let me put this back up here. Okay, so 1 away from the number 1 carbon is ortho, 2 away is meta, 3 away is para. So you can use that as well. Okay, now let's draw these structures. I'm going to go to this real quick and draw them on here. Okay, so first we have 1,3-trimethylbenzene. So I'm going to start by drawing my benzene ring. So we have 6 in the ring, and then don't forget your double bonds. Okay, so there's my benzene ring, and I want to put 1,3,5-trimethyl. So there's 3 methyl groups. So here's 1, and that's 2, 3, 4, and 5. So that would be 1,3,5-trimethylbenzene. Okay, number 2. We have nitrobenzene. Okay, so I'm going to draw benzene. And remember, nitro is NO2. And it doesn't matter which carbon I attach it to because it's always going to be 1 since there's no number prefix on there in the name. So I can put it wherever I want. Oops, that's 3. Okay, number 3, 2,4-dibromophenol. So we're going to draw phenol first. So the benzene ring. And then we're going to put the OH group on. So OH kind of determines where everything else is going to be. So I'm just going to stick it right here because that's going to be carbon 1 that's on. And then 2, 3, 4 is where our bromine is going to be. Okay, number 4 is 2-phenyloctane. Okay, so here's an example where the benzene ring is going to act as a substituent. So I'm going to draw octane. So 1, 2, 3, 4, 5, 6, 7, 8. So that's octane. And then it says 2. So this is carbon 2 right here. And I'm going to draw my benzene ring on carbon 2. Okay. Okay, now number 5. Number 5 says parachloroaniline. So remember, aniline is the benzene ring with NH2 attached to it. So we draw our benzene ring and put NH2. And remember, para means that it's 3 carbon away. So switch. So here's 1, 2, 3. So I want to put my chlorine right there. Okay, then number 6. We have 4-bromo-3-chlorophenol. So start by drawing phenol, which is the benzene ring with the alcohol group or the OH group. Okay, so again, the alcohol, the OH, is going to determine where everything else is because it's on carbon 1. So it says 4 and 3. So we have 1, 2, 3 is right here. That's going to have our chlorine, and 4 is going to have bromine. Okay, so now we went from the name to the structure. Now we're going to go to the structure to the name. So I'm going to come back over here. Okay, so the first one So you should have that on your notes. So I'm going to just stay on this page right here. Okay, the first one, we have CH3, 1CH3. So we have toluene there. And then we have 3 nitro groups. So we're going to start with nitro. Well, so the toluene we're going to put on carbon 1, and then we're going to number the nitro groups. Let me go back over here. Okay, so this is carbon 1, 2, 3, 4, 5, 6. So we have a nitro group on 2, 4, and 6. So 2, 4, 6, and there's 3 of them, so we have to say trinitro. And then we can just say toluene. Because again, it's understood that that CH3 is going to be on the first carbon. Okay, let's go back here. Okay, then again, we have this methyl group. So that's going to make it toluene. And we have 1 nitro group this time. So this is on 1, this is on 2. So this one is going to be 2 nitro toluene. Okay, let's go back to 3. Okay, 3, we have the OH group, so we know that's going to be phenol. Okay, so this is the first carbon, second, and third. We have the ethyl group here. So we're going to have 3-ethyl phenol. And then number 4. And on that one, you could have used meta. You could have said meta-ethyl phenol instead of 3. Oh, that's not what I wanted to do. Sorry. Okay, on this one, we have the NH2 right here. So we know that's aniline. So we start with numbering here, 1, 2, 3, or you can use meta in this case. So we'll do that since I didn't do it on the last one. So it's going to be meta, bromo, aniline. Okay, number 5, we have the OH group, so we have phenol. So we're going to start numbering 1, 2, 3, 4, 5, and 6. So we've got bromine on carbon 2 and chlorine on carbon 3. So we're going to start by naming bromine because we want to stick with the alphabetical order. So it's going to be 2 bromo, 5 chloro, phenol. Okay, last one here. Okay, so this is just a benzene ring. Okay, it's not one of the common names that we saw. So we have a benzene, we have isopropyl over here, and we have ethyl over here. So we can start, or we can just use meta because there are only two carbon difference there. So we're going to start with meta, and we want to use the alphabetical order. So we're going to say meta-ethyl, isopropyl, benzene. That's a long one.